Okay, everybody. Welcome to week 11.
Is that what week we're on?
It's week 11. We got four left.
I was thinking 3.
Well, it's 3 weeks. It's 3 full weeks after this one, and then finals.
So I was right.
So there's four total. Three more full, and then finals, and then it's party down. Spring break.
Spring break.
Oh no, summer break.
Summer break.
This semester ripped past. Where was I on spring break? No, I think I was just working.
I was sick.
All right, let's just do the PV Watts exam, shall we?
Let's do it.
Dink, dink, dink. So PV Watts.
I mean, are we supposed to use this PV calculator thing?
I don't know. Let's check it out. Let's just dive right in. Guns a-blazing.
Because that's what I did, and we confused the crap out of me.
Well, let's just see. So I've got a couple people taking it. Let's dive in and take it. Turn editing on. Okay, there are 8 questions on the PV Watts quiz, and we're just going to dive into it cold and see how we do. First question. I feel like I'm on Jeopardy. Oh, so my daughter and I were at UC San Diego, and as a little icebreaker, they played Jeopardy. Got the first one right. Tesselman curve.
Ah.
Climate change. Have you heard of it?
Yeah.
Yeah, Tesselman curve. I busted it out, though. All right. Calculate the estimated AC energy output from a 2100 watt DC system flush mounted on a 612 pitch. Use the default D rate factor. Okay. Let's dive in. Let's take a couple notes. And the other thing I learned yesterday, sitting in a meeting, someone said, hey, Professor Layton, professional engineer, tell me how many tons of woody biomass I'm going to burn at Hardin Generating if I convert it to wood from coal. I dove right in and I started using Microsoft Excel, got myself sideways, roll on back. Sat down, solved it, pencil, paper, ding, boom, nailed it. So let's just start there. Yeah. Yeah, I mean, we are obviously going to have to use the software for this, but let's at least cycle it through the brain, mind, paper, pencil, gyre a couple times. Okay. 2100 watts. So it's a 2100 watt DC system. DC. Now it's going to go through the inverter. It's going to come out as AC, right? And from there, okay. Flush mounted 612 due south. So 612 side view. Here's your 12. Here's your 6. And so we'll run the angle on that. So, and yeah,
27 degrees.
so let's just do theta. Tan theta equals 6 by 12. Theta equals tan minus 1 of 1/2, right? Just throw this at Microsoft Excel. It's one of those where you kind of should remember if you took trig recently, but I didn't take it recently enough.
That's why I like my calculator. I don't know what I just sit here and tell me. I usually never leave home without it, but I might have today.
Okay, so here we go. Equals A10 0.5. Now, let's blow this up. So arctan of 1/2 is 0.46. That's in radians equals degrees of our answer 26. Is that what you got? Speedy.
I Googled it.
Oh, sneaky.
Google's pretty smart when it wants to be.
27 degrees. There we go. All right, 612. Use the default D rate. Your answer should be in units of kilowatt hours. Let's do it. Let's do it. PV watts. What else do we know about this system?
2100 DC watts, flush mounted.
Where on earth is it? Would you just assume it's in Missoula?
That's what I did.
All right, let's do it. Get started. 101. Higgins Ave.
Oh, I just did 5902.
Okay. That's fine. 59802. Okay. You can get smarter all the time. Go to system info. DC size 21 hundo. Module type standard. Let's not mess with that. Array type fixed, right? Because it's not. Well, let's do fixed roof mount.
Yeah, roof
I don't see a whole bunch. This is our D rate. That's our system losses. Use the default. That's fine. 14. Let's do 27. Azimuth. That's due south. That's it.
167.
Say what?
167 degrees is true south. Here in Missoula, isn't it?
Well, let's not overthink it.
Okay.
I mean, we could put in 167. I'm fine with that, but let's go first order approximation.
Okay.
Module type residential. Go to results. All right. AC.
Wow.
Kilowatt hours. Take that. I'm going to copy it. I'm going to knock it back in here to that. Guy, file, save as,
Take your thumbs out.
save as, computer, documentaise, wake up, wake up, wake up, wake up, courses. NRGY 243. What week is this, please?
11.
What week quiz are we doing though?
11. Oh, no, this is 4.
Week 4.
3.
Week 3. Open. Open. Oh, I saved this book 1. Okay, so this is problem 1. P1 2100 watts DC. All right, so I'm going to just throw that in there. We want this in, that's in kilowatt hours, isn't it?
Yes, it is.
All right, that's what we want.
And then you gotta put your input in.
Oh, nice. DC. All right, so let's put that in. DC equals 2100 watts. Module standard, array fixed roof. Module standard, array fixed roof. Losses 14, tilt 27, loss 14%, tilt 27 degrees, and azimuth $1.80. Okay, next. Calculate the estimated AC energy output. The array is on a true south pole mount with a fixed tilt equal to latitude. Okay? Open rack?
That's what I'm thinking, that would go now.
Yeah.
Okay.
Where are we at, 46? Facing south? So we didn't change much. 2618, let's throw that in here too. Not much at all. So this is P2, which is P3, 2100 watts DC pole, and we were at 46. I'm just going to put the answer in. So we're 2.6, what was it, 2.62?
2.625.
Gosh, almost identical.
Almost.
Let's just take this guy, copy. Take this guy, paste. Okay, standard. This is pole mount. Calculate the history. Orientation is magnetic 121. Still pole mount. Okay, so the only thing we're changing is the is this guy. A little less. Okay. Okay. Standard output from PV watts. That's too much.
That's always too much. Turn it off.
Binary. Standard output from PV watts gives estimated production on a monthly basis. Use these data to calculate the estimated annual AC energy. So the array is adjusted seasonally. So we're going lat minus 15 on April 1st, so we're going to get summer. lat plus 15 on October 1st. You know what, here's one thing I gotta figure out. I'm not sure what, here, let's do this. How do I get a new place? I don't want to be in, change location. I want to go to the equator. Ecuador, fine, pretty close. So let's do a tilt of 0. So I don't know if 0 is vertical or horizontal. You know what I'm saying? I can't remember. I just did 0, and I got a lot, right? Now let's do a tilt of 90. I got a lot less. Okay, so that's what we thought. So 90 is vertical, 0 is flat. And that's the way we did it before.
Okay. 0 is vertical.
No.
No, horizontal.
Yeah. Yeah.
Yeah, I know.
Yeah. That's right, because I just put in 90, which would be, yeah. Okay. Change location. 2, go. Go to system info. And the question says, use the data from question 3, which was this one. Oh no, question 3 was this one. Pole 1446. So we're going fixed, pole, system losses, 14, that's the 5. Okay, now we're going to run it twice. Azimuth is 180. Let's make sure we got the azimuth is 180. Yep. We're going to run it twice. Now, lat minus 15. Again, let's do it on the picture. Okay, so this is 0. This is 90, if this is the ground. If we're, here on Earth, and we're at 45-ish, a 90 would look like that. A 0 would look like that, and a 45 would look like that, which is handy because the sun's over here. Okay, so now so let's just, so this is 90, this is 0, we'll just call this lat. Nice. Okay. So lat minus 15, April 1st. So this is basically lat minus how many? 15. When we subtract, we go closer to 0. So lat minus 15, lat equals 46. Lat minus 15 equals 46 minus 15 equals 31. Okay? We can do that.
46, or you mean 45?
Well, I think we're at 46 degrees north here, aren't we? 46, 47, I think it's a little more. I think we're right above 45. Let's just check. I think the Google knows this too.
Bet you they do.
Lat, Lon, Zula, Montana. It's almost 47. Yeah, almost 47. Okay, so going to PV watts. Dink. Until, call it 31. Probably a little closer to 32, but fine. Not bad. And now go to results. Look at that.
Not too bad.
So I think we might even just go like this. Copy. Tab.
Copy in April's.
Yeah, and we're going to call this P7. We go here. Come on. Wake up. Paste. Give me some love. Give me some. Give me some. Give me something. Oh. Let's go over here. How about print results? I thought there was a little way to export to Excel, no?
Import?
Export to Excel?
Yeah, sure. I just copied and pasted it.
In Excel?
No, into
Word? Into what?
the quiz. What are you copying and pasting? Like,
Well, I don't know.
just quiz?
Let's call this minus 15. Give me one quick second. Man, it's taking a long time to print. All right, so we're just finishing up the last problem of the quiz. This is the PV Watts quiz. And let's just go back and dive into it, remind ourselves. So we're doing latitude minus 15. Make this a little bigger. We're doing latitude minus 15 on April 1st, and we're doing latitude plus 15 on October 1st. So what we did was just went into the system, went into PV Watts, and typed in both answers. So lat minus 15 is 31, lat plus 15 is 61. Let's go ahead and redo that, guys. So, redo it correctly this time. 14, and we'll do 61. So again, what you can see here, 2100 watts, standard, open fixed, 14, and we're going to do 61. So effectively what we're doing is a tracking array with 2 positions. So we just put in fixed and put in the 2 different positions, get the results for both. And so here's our 61 that we change it to on October 1st. We will go to PV watts, output. I did not see an Excel exporter, so I'm just going to copy these right out of the HTML. I'm going to go to my October, and I'm going to paste, and file, save, and now I'm going to go into Excel, and I'm going to open computer, PV watts, sorry, kind of slow today. Kind of pokey. And I need to go to all files. First I'll open April, text file, and I want delimited. Next, and I'm going to do a space. Next, and finish. All right, so there we go. So now I've got April. I'll just take this and copy it. Take it back to problem 7, and we can see this is the data that did not come in correctly. Now we'll come in here and paste it. Oh, much better, much better, much better, much better. Much better. Get these guys all tidied up. And this is our kilowatt hours. AC. And we'll just highlight these guys. That's what we're after. And we'll draw a little box around these bad boys. Okay, and then we will go back to October. That's fine. Actually, I'm going to close it so we don't have it open in 2 different instances. And I will close that, and I will open another one. Computer, October, open, delimited, next, space, next, finish, looks good, copy, go back into my solution, paste, clean this up, take that, copy it, paste it. This is April. This is October. Bold, bold, bold. Bold, great, great. Here we want these instead. These, dink. Dink equals that. Copy. So we're just going to take the 3 values, January, February, March, that we're going for October, or more or less the winter months. And then this equals these guys. And we'll run that again. Okay. Then we'll say this equals this guy, and we'll run that again. right, so just so we can see this a little bit better, what I've done is copied for my, this was lat minus 15, and this was lat plus 15. And in this case, I just copied the 3 cells for the first 3 winter months. Here I copied the middle months, the 6 summer months, and then the last 3 winter months. So I've got the best of both worlds equals sum, open parens. There we go. Nice big number. 2.4, okay. So 2.4 million kilowatt hours. Nice. Nice. Oh. Now let's see if we did something different. If we let this equal that, let's see if we just kind of ran the thing counter optimally, counterintuitively equals that. So we're basically tilting the array backwards. I just want to see what the percent different was. So, looks like I got different. Gosh, I'm glad I checked. Okay, I made an error. That's fun. Let's just go double check it. Go to tilt degree 69. Gosh, it can't be exact, can it? This is plus 61. Wow, it is exact. Okay, we need to double check. Having a moment. We're having a moment. 1461. Copy. Yeah, something's a little bit wonky. Notepad. Paste. File. Save as. And I'm just going to call this October 2. Do it again. I'm going to go 31. Go to results. Hopefully this is different. Copy. Go back to Notepad. File. New. Paste. File. Save as. April 2. So I'm just redoing this with a new name. Now let me go to Excel. I'll close that, and then I will open. No computer. PV watts. Let's just start with April. Next. Space. Finish. Copy. Okay, I think I just made an error on the April before. Paste. Save. Open. Computer. PV watts. October 2. Open. Delimited. Space. Finish. Copy. Paste. All right, so now, okay, now they're obviously different. Okay. Woo! Okay. Yeah, I think all I did was I just did October twice accidentally, so it's just. And here again, what I'm doing, what you can see is I've saved my incorrect answer, tracking my error. So let's just go ahead and copy this, paste it over here. Now I should just be able to take this whole thing, optimal, suboptimal. This is suboptimal in other ways. Now let's just take this whole thing, copy. Paste. Insert a little slide here so we can see better. Ah, there we go. Okay. And then percent difference equals that over that. Throw that in as a percentage. There we go. Okay. So what we did, just in summary, is we got an extra 11% performance out of our system. No, wait, well, maybe not. Let's do it, no, we'll do it another way. This would be, I guess there's 4 different things to compare. Let's copy this, sum it here, we'll also sum it here. So the optimal is, if we go April, October, we'll see what kind of performance we got. So if we just left it here, we would have this divided by this. So 2% increase in performance here. Let's do the same thing, equals October over optimal. That's where we're really getting the big bang for our buck. The biggest bang for our buck is doing that winter setting, doing that summer setting. Yeah, so by optimizing it for summer, we get a much, if we just left it in the winter setting, we'd get 91% less than if we optimized it. If we just left it in the summer setting, we're 98. So we're getting a pretty good bang by pointing that array at the sun. An extra 9% there. 2% there, and that's the total 11 over being suboptimal. So, hey, that was fun. Love doing PV Watts with you. Let's throw the answer into the quiz and see how we did. Standard answer. Copy that. Paste it back here, take the commas out. Show your inputs. I'll just say 31 tilt 31 April through September, tilt 61 October through March. Everything else was the same. Finish attempt. Answer saved. Submit and finish. Okay, so if these numbers are coming out right, it's just because of a slight difference. I'll go in right now and just see what the grading scheme is and fix it away. All right, everybody. See you next week. Thanks. I'm out.